What? There's an outage in India and anyone can order free food on Uber Eats? Yes, this actually happened. For a whole weekend, almost anyone in India could order free food on Uber Eats, and I was in the middle of this. See, I was the engineering manager of the team that owned payment methods in India, for Uber Eats included. And so a team member of mine got the outage alert and we were the ones investigating, trying to solve what happened and why. In this video, I'm gonna walk you through what actually happened, tell you the story, and we'll talk about why idempotency, breaking changes, and mapping errors are actually hard. Hey, this is Gerrit with The Pragmatic Engineer, where I talk about software engineering, engineering management, and big tech and startups. If you like this content, sign up for my newsletter, The Pragmatic Engineering Newsletter, which is the #1 technology newsletter on Substack. It's the most read newsletter for software engineers and engineering managers. It's free to sign up. There's also a paid version. If you have a learning and development budget, you might be able to expense it. A lot of subscribers do. So now let's get into the actual incident, but I have a few disclaimers. First, this outage was a few years ago, sometime in 2018 or 2019. Now, I'm no longer with Uber. I haven't been there for about a year and a half, so I'm recalling a lot of these from memory. I'm gonna do my best to represent things accurately, but there might be some gaps. So here's a question that someone asked on Quora related to this incident. What was a glitch on Uber Eats app that enabled users to get free food while paying for the order through an empty PayTM wallet? And someone in India replied that this incident was hilarious. They lived in a wholesale university. And on the afternoon of March 3rd, 2019, so I guess it was in 2019, the news of the glitch escalated to the university and college students basically ordered a bunch of free food. So at this point, I've been the engineering manager of what is called the rider payments team at Uber for about 3 years now. We owned all the payment methods globally that people could use in the rider app initially, but later we integrated with things like the Uber Eats app as well. So the PayTM integration was something that we owned. Now, PayTM is one of the largest payment methods in India. You can think of it as like the Venmo for India, except it's a lot bigger. They recently went public as far as I recall as well. And so college students started to capitalize on this, and here's something from Twitter. Someone saying that in their city in India, ordered around $14,000 of free food in just one city, and here's some pictures of all the stuff that they ordered. So what actually happened? Well, first of all, there is clearly a payments related bug here. And I know this because my team was alerted. We were the ones who eventually fixed it and worked through all of this. Now, to understand the bug, let's talk about the original functionality first before this bug was introduced. So here's how stuff worked. Uber had a mobile app, Uber Eats, Android, iOS apps, even on the web, and these apps talk with Uber's backend. Now, what we did, talking with different payment providers, including PayTM, which was one of the providers, when the user was finalizing their order, we said, all right, charge this wallet, assuming it has enough credits, and then just take it off. And then PayTM would return a success or an error. Now, when you didn't have enough credits, they just returned an error. Or they could have, returned an error for whatever reason. The user is banned, or they're under investigation, or it might be some other reason. Then what at Uber, we offered users the opportunity to retry, because who knows, like maybe they topped up the wallet afterwards, or maybe they did something. And if they didn't have enough credits, we just got the exact same error. So our assumption at this point that this endpoint was idempotent for this use case. Idempotent means that an endpoint behaves the exact same way when you try to repeat a transaction. Now, those of you who are familiar with idempotency might say this is not real idempotency, and you would be right. This would be real idempotency if there was a transaction ID or an idempotency key that we passed in. Now, as far as I remember, there was no specific idempotency key that we passed in here, but I think there might have been a transaction identifier. Regardless of how it is, on the side of Uber, we were pretty convinced that we can just keep retrying, and either we'll eventually get a success, or we're just gonna get error messages back, and these are the two things that can happen. And this integration worked really well for 4 years. So integration was built in 2015, even before I joined Uber, and it was humming along beautifully. We barely had to change anything on this backend code. We might have had a few small changes here and there, but nothing major. You build it once and it works with some maintenance. Now, before I go on what happened, just a few notes of how Uber systems were built, just to get ahead of some questions that a lot of people had. First of all, did we have unit tests? Yes, we had unit tests everywhere. Well, we had unit tests always on the back end. We had it on the mobile client as well. But on the back end, we did have all the use cases tested that this API could behave in. So we were just obviously mocking it. These were not integration tests. We did not have integration tests with most payment providers just because they're a pain to do. Some providers didn't have integration environments. I'm not sure if PayTM had it at the time. As far as I know, they did not, but maybe they have it now. So we had unit tests that ran on every commit, but not integration tests. Now, how did PayTM send those responses back? They sent us HTTP 200 responses with a JSON message. So the only way for us to know if it's a success or failure is we had to parse that message that came inside of it. Now, those of you who've been building APIs, you might kind of frown and say like, whew, 200 responses. This is not really the best thing to do. And so there's this comic that comes to mind where the front end is getting a message from the back end here. And the message says 200 okay. And the front end is like, yay, it's a successful response. But then you read the details and in the JSON object, there's an internal server error 500 and the front end is upset. Now the reason this humor is funny because if you can, you should use HTTP status codes to communicate what is going on. Is it a success or is it an error? So you might frown saying, what? PayTM was sending back a 200 successes? And this is actually pretty common among payment service providers. This is really common in the payments world. The reason is that sometimes the statuses are not as simple as black and white. There might be in-between statuses. There might be cases where a successful charge has been initiated, but it hasn't gone through, etc. And HTTP statuses are great for building the kind of the web where you're serving web pages, but they're not as great for payments infrastructure. And so I said PSP, by the way. I'm using a little bit of terminology here. That is, if you work in payments, you see it, but PSP means payment service provider. So the likes of PayTM, Venmo, Google Pay, Apple Pay, Stripe, PayPal, credit card processors like Braintree or even ZachPay, all of these are payment service providers. You can just think of it as APIs where you tell them, all right, take the payment and they'll be able to do it or not. And my team at Uber, we integrated with about 15 different PSPs, payment service providers. I did a video where I talked about all the different kind of payments challenges we had to solve at Uber. This video is linked above and it talks about Uber's app side, but it also goes into why Uber has a lot of functionality. And for example, why we had to add in 15 different payment service providers, a lot of them using their SDKs, which was shipped in the global Uber app. So back to our story. One fateful Friday night, something changed. Suddenly, by the next Saturday, people were able to order free food. And let's see what actually changed. So remember how we had this use case where when we charged without enough credits, we got an error. This was still the same. But when users hit a retry again, and we tried to charge the wallet that did not have enough credits, we suddenly got a new response that we've never seen before at Uber. This changed. And so this, there were two problems with this. First of all, there was a new response that we didn't know about. Somewhere, someone at the payment service provider side made a code change and they just returned a new object and they kind of forgot to tell anyone about this new response. The second was that this behavior was no longer what we considered idempotent. We were expecting to always get the same error back when there's an error, but now we got something else. This was, as far as I recall, it was some sort of status. It wasn't an outright error. It was more of a status with not enough balance or something along those lines. In all fairness, this endpoint never guaranteed idempotency. I told you that we did not pass in an idempotency key, although as I said, there might have been a transaction ID key, which might have been something similar. But more importantly, PayTM, the service provider, they did not say this was idempotent. This was just our assumption at the Uber side. So now, what happened is what you can probably think about is our backend said, that's weird. We've never seen this before. It's not a success, but it's definitely not a failure. Like when our message parser looked at it, it is not a failure. And we decided to fail open. So I'm going to pause for a second because this is yet another kind of technical term. I guess this video is turning into some introduction to payments. Failing open versus failing closed. This means what happens when you encounter something unexpected. Failing closed means you shut down. As soon as you see a message that you're not expecting, or you see an exception, or something does not look right, you just don't do anything. So what this would have meant if we failed close is we just cancel the transaction. We say sorry, something went wrong. We give you an error message and we don't send the order. We don't do anything. Failing open means you see something that is unexpected. you still go ahead, knowing that this thing is unexpected and you'll need to figure it out later. And this is what Uber did. So we actually had this strategy from the early days of Uber. In order to maximize growth, we would often fail open. So for example, our payment service provider will be down for an hour, which happened a lot at the early days of Uber. You could still use Uber. You will still order your ride. You could still order food. The credit card processing provider might have been down. And it still went through, and then later when they came back up, we would charge them and we would just settle behind the scenes. Now, failing open does have the risk that you might be paying out of your own pocket. As we'll see later, this might have been the case here, but it has the advantage that it's just a frictionless experience where you kind of trust customers that, what they're doing should be fine. You'll probably be able to recover that money. And failing close, it gives you that frustrating experience. When you can't log into your bank because, something is happening. The banks typically and payments are typically always failing close as soon as they see something. But as I said, the interesting thing with that, when we built this payment provider in 2015, failing open was the norm, and it was what the business wanted. This was not just some cowboy decision. This was a very deliberate decision that we did in every payment instrument pretty much that we built at Uber. So then what actually happened is we got this new response. We decided to fail open and we started to send food people's way. And very quickly college students discovered this and they started ordering a bunch of free food. They told their friends who ordered even more free food, and it just snowballed into this huge thing. So how did we discover the bug? How did we see that something was going on? And I'd love to tell you that we had some sophisticated monitoring and AI driven and ML and all that. It wasn't like that. It was done in a very manual way. In India, we had what is called an operations team. There are people who are responsible for the health of the marketplace, and they look at all the graphs. They make sure that the marketplace is healthy, enough people are ordering, enough restaurants are open. On Saturday, they didn't see anything going wrong, even though there were already more orders. But Sunday, I think midday, they started to see that a lot of restaurants are going offline. They're closing. They've been open for like 2 hours, and they closed up. And the supply was going down. People couldn't order enough things. And so they called out some of these restaurants and they asked what's going on. And the restaurants were like, oh my gosh, we've never seen this many orders. Like, people are ordering these like huge bulk orders and it's all these students. Like, we don't know where they got the money from. And so the operations team looked into like, hold on, this is really, really weird. So they pinged different people, and ultimately one person on my team, the on-call engineer, got paged. We saw what is going on and we're like, this is just abnormal. Like, we've not seen this. So we shut down the PayTM integration. We use a remote feature flag that we did for mobile apps. And by the way, if you're interested in like feature flags, using them at large scale, I wrote a book called Building Mobile Apps at Scale. Well, I also talk about this. The point is, building a mobile app has a lot of different challenges that are related to backend. So in this case, it was great that Uber had a remote feature flag. We could just remove PayTM. People could no longer pay with PayTM. Obviously, a lot of people were upset, but we actually just stopped the outage from happening. And then we looked into fixing what actually was going wrong. Obviously, the way the fix went is we saw like, oh, we now see these new responses. We should code defensively. So we did. We shipped this new version of the code. We tested that it worked. We turned it back on. And as far as I remember, the next day, PayTM was back on. So there was half a day where people couldn't use this payment method. And then we had to look into, like what the actual loss is and how we're gonna reconcile that. But I'll get to that at the end of the video. So what were the learnings from this? Because there were plenty of learnings on both sides, both on Uber's side as well as on payment provider's side. And I'll start with Uber's side. And by the way, these are the learnings that my team internalized and I also internalized as well. The first obvious thing that most of you will probably think is, maybe Uber should have failed close. You see an unknown response, we should have just said, you know what? We're not going to do any order. People can keep retrying infinitely and nothing's going to happen. And, we're not going to send any orders if you don't have any balance. Even though the payment provider changed their API, we just see something unknown and we'll be like, ooh, we're not sure. We're not going to do anything. It's not a success, right? And it is a sensible approach, but this might still get you into trouble. And I'll show you on LinkedIn, someone wrote a response that they did just this at their startup. Here's what this person said, Ravneet Singh Khalsa. In my company, we had the exact opposite issue. The payment partner changed their contract and we interpreted unknown status as bad, causing people to keep on retrying payments. So they said, oh, we got an unknown error, it did not go through. And people were charged multiple times while they were told their payment failed. So by failing close, you actually do have the risk of double and triple charging people, which will obviously make them upset. Now, by failing close, you're definitely not going to lose the company money. So you need to decide what is your priority. If your priority is growth and you've got a bunch of money to spend, like Uber had in the early days, failing open actually makes sense. As much as I cringe at the idea, but it does make sense. We were doing the sensible thing. If you're short on cash, you're a startup, you cannot afford to lose money, but you can afford to upset people, fail closed. You know, this startup, their customers were probably really upset that they got charged multiple times, and they got their money back eventually. But again, they kind of broke that trust. So this is the interesting thing, right? Uber was really cautious on not breaking people's trust early on, and they paid a little bit of money for that price. Now, one thing that we should have done is alert on unknown responses. As soon as an unknown response, or at least multiple come, we should have been paged. Like, our on-call engineer should have not been pinged by an operations person who just got off the phone from a restaurant. We should have seen that, holy moly, we're getting all these unknown responses from this provider, and what is going on? We should have done that. And this is a learning going ahead. If you're building any payment system or anything that is moving money, if you see something unknown, send an alert. Like, you need to handle that and look into what that is. The third thing that we probably should have done is just agree a lot better with our payments provider on what breaking changes mean and what they should alert us on. And breaking changes are a little bit of tricky territory because there are some things that are super clear to do. So for example, changing, I'm just going to move things around here. So for example, changing the API signature is definitely a breaking change. So if you're changing what kind of parameters you do, like, that's clear. You need to communicate that, and that is clear for the API provider, and it's clear for us as well. But what about changing an endpoint that kind of behaved idempotent for most of the time, like this charging when you don't have enough balance, but now it's behaving differently, like the second call and the third call, it just returns something different. Is this a breaking change? And you can look at it from both ways, but there's no, some people will say yes, it is. Some people will say no. Some people will be in between. I'm personally a bit in between because for a provider that is proud of their API, they will treat this as a breaking change. But then, for example, is returning a new type of message a breaking change? This one I think is a bit more clear than the previous one. I think when you return a new message, which is new semantics, that should be a breaking change, and you should consider that because you'll have clients who just don't know how to parse it. And our example shows that if clients fail open, they'll start to, not charge people. And if they fail close, they might actually double charge people, just like we've seen in this example here. So that's some things that Uber could have done differently. What about the payments provider? I mean, they could have done a few things differently if you ask me. At first, they could have documented statuses a bit more clear. There could have been very clear what is a success and what is a failure. And as I recall, there was some sort of documentation there. It was not really clearly communicated at that point. Later, this got fixed. The next one is just notifying customers of API behavior changes. So if anything changes on your API, you should tell people, hey, FYI, it's going to change. Now, I do think that a new message return should be a behavior change. So I think, a provider should communicate that up front. The next one is rolling out changes to the API in a staged fashion. So, this payment provider, they just, on a Friday night, they just press the button and boom, all their API just started to behave differently. It wasn't just some part of the API. It wasn't a rollout of like 10% for a week or something. It was the whole thing. Now, this is a risky change, and I think if you're a payments provider, you should not do this. You should do a lot smaller and incremental changes. Now, on one end, if they did this, it might have been harder to catch because it might have been like, oh, some college students are able to order. But again, I think it's just good practice of deploying high-risk changes gradually or to certain customers. And finally, make changes during business hours to the API and give a heads up. A big problem with this change is that it went out Friday night, and this was in India who were ahead of. So I think Friday night in India is like Friday afternoon in Amsterdam. And the change really came into effect on Saturday where no one was around except for the operations people. And you saw that even it took them like another day to even cache this. So I'm not against Friday deploys because I think you should be able to deploy any time of the week. But if you're a platform who has a bunch of dependencies, if you deploy on Fridays, you should at least send out a broadcast saying, hey, I made this change, just keep an extra eye out. And this is also true when you're an internal team within a company. Deploy on Friday by all means. Obviously have your tests covered, but just let some of your dependencies know that something is going out, especially when there's a behavior change on your API. Again, if you can deploy whatever that doesn't change the API, but if behavior changes, I think it's a breaking change. So in the end, how much was the damage? Well, I cannot tell you an exact number, but it was a lot. And you saw that estimation of $14,000 for a single city. That sounded about right, except Uber had like dozens, probably more like hundreds of cities. So, you do the math and you can imagine it was a big hit. My team actually, we were the payments team, so we saw a lot of gains, but we also saw a lot of losses. This outage was my second biggest loss while I worked at Uber. Almost over 4 years, that was on my team. There was another outage that cost us actually way more money than this one, but that's a different story. So who paid for all this free food in the end? The restaurants got paid. The people who ordered our free food, they were never gone after. So, it was a big win for them, honestly. And so the entity that actually paid for this is whose fault this incident ultimately was. Because that's how you settle things. So obviously Uber and the provider sat down and we talked through, we saw what we could have done better or worse, and we got to an agreement of whose fault this ultimately was. Now, I cannot share, unfortunately, what the settlement was, who paid and how much, but I am curious, what do you think? Whose fault was this? Was it the fault of the API consumer? Because they did a lot of mistakes, which is actually my team. We failed open on an unknown message. We did not alert when we saw a new type of message. And honestly, we didn't have enough defensive coding in place for foreseeing future cases. So when we built the integration, it worked fine. But 4 years later, we didn't predict that a new message would come. And again, we didn't fail close, although that was partially a business decision as well. Or was it the API provider for changing their API behavior without communications? Even though it wasn't a huge change, it was a subtle change, but something changed there. For doing this on a Friday night, I wouldn't count that against them, but as a provider, it's not a great thing to see. Or for providing implicit idempotency that was never documented, and then that behavior just changed. So please leave a comment below. I'm also starting a poll on the community section, so you can also vote there. I'd love to hear your thoughts on this one. If you're in tech, subscribe to my newsletter at pragmaticengineer.com. Also, like this video and subscribe to not miss topics on software engineering, engineering management, and big tech and high growth startups. Thanks, and see you at the next one.